In this video, we will discuss about the optimization of the lipid nanoparticles so that it can deliver to the tumor-associated macrophages. So in this case, what they did is they have exploited the eat me signal of the macrophages or the tumor-associated macrophages, that is phosphatidylserine. So what they did is they combined this phosphatidylserine with this lipid nanoparticle at different ratio and find out the optimum conditions at which it will be inserted, or the mRNA that are inside this lipid nanoparticle will be inserted into the tumor associated macrophages through phagocytosis. So when they use at different molar ratios, they are able to see that at the molar ratio of this 5, they are able to see maximum transfections or maximum insert of this mRNA, or the maximum expressions of this GFP mRNA that are present inside these lipid nanoparticles. And they checked it at this raw 264.7 cells, and they also checked it with bone marrow derived macrophages. For both the conditions, they are able to see that at the molar ratio of 5, the results are they are able to see maximum flux. And thereafter, they wanted to check these conditions in a more realistic system, and for that they used a coculture system of melanoma cancer cells and also this bone marrow derived macrophages. And what they are able to find out that in this coculture system also there is a preferential transfections of this lipid nanoparticles occurs into this bone marrow derived macrophages compared to the tumor cells. Once optimizing the conditions for the mRNA delivery using this modified phosphatidylserine lipid nanoparticles, they also wanted to optimize the conditions for the STING co-stimulatory domain. So in order to do that, they co-encapsulate this STING agonist along with this mRNA in the lipid nanoparticles. And in that case, in order to optimize the conditions, they use the mCherry signals for the mRNA, and they followed the same procedures. That is, they use the different ratios of this STING agonist to this modified phosphatidylserine lipid nanoparticles, and they are able to see that inverse phenomena, that is, with increase in the agonist amount, they are able to see a decrease in the CAR expressions or these mCherry signals in this case. And with increase in the STING agonist, they are able to see more activations of these macrophages, which is monitored or which is checked by the CD86 expressions from the macrophages. So this inverse relations has led them to find out the optimum conditions where they will see enough CAR expressions. At the same time, the optimizations of the activations of the macrophages is also enough to see the cytotoxicity effect against the tumors. So for that, they check this viability of the macrophages, where they are able to see that at around the 8:1, they are able to see viabilities which is comparable to the control case, that is when they don't use any STING agonist. And at the same time, at high doses of this they are able to see some cytotoxicity effect against the tumors also. The results are not shown in this main figure. So from that, they come to a point that this mRNA and the STING agonist co-encapsulations at the ratio of 8:1. At the 8:1 should be the optimum conditions that can be used to check that their system or their platform of this, or their idea of the in vivo CAR expressions through this modified lipid nanoparticles, that is phosphatidylserine lipid nanoparticles, can activate or can form a CAR expressions on the macrophages. At the same time, the STING agonist will helps in the activation of the macrophages, thereby through the phagocytosis these macrophages can kill their nearby tumors. So far, the optimization conditions, two optimization conditions has been discussed here. First one is the specificity to deliver to the tumor associated macrophages, and second one is to have enough activations through this sting co-stimulatory sting agonist that is co-delivered along with the lipid nanoparticles. So this is what has been discussed in this figure. If you need to understand more about these experiments and these results in detail, you can go through the reference that has been provided in the description. That's all for this video. Thank you for your time.